in 6.2, we are solving trig equations. In order to solve some trig equations, we are going to have to use some inverse trig functions. So that's why we did 6.1 first. Let's look at 6.2. First of all, it says solve 2 times sine theta minus 1 over the interval, and it gives us the interval from 0 to 360 degrees. So from 0 to 360 degrees is what we're talking about, right? Obviously, it wants the answer in degree mode. Do you agree? All right. So looking at this equation, if we're trying to get sine theta by itself, what do I need to do? Add 1, right? Just like if you were trying to get, if sine of x or sine theta was x, if you're trying to get x by itself, you'd add 1. So now we have 2 sine theta equals 1. Now what would we do? Divide by 2. So sine theta then equals positive 1/2, yes? Okay, so where is sine positive? Which quadrants? 1 and 2, yes? So what we're talking about is we're trying to find this angle theta where sine is opposite over hypotenuse, 1/2. Is that a special right triangle? 1 square root of 3 and 2, right? What would theta have to be there? 30 degrees. Does everybody understand that? Yes? Now, not only that, but we also know that it's positive in quadrant 2, yes? So this would be our reference angle here, and we know that reference angle would also have been 30 degrees. Do you agree with that? But I need this entire angle right here. So how would I find that entire angle? So for quadrant 1, we know it was 30 degrees. For quadrant 2, to get that, we would have done 180 minus 30, yes? Which is 150 degrees. So there's 2 answers there, 30 degrees and 150 degrees. Everybody understand that? Questions? Okay, let's look at example 2. Again, it's talking about between 0 and 360 degrees, right? Okay. Now the problem is we have multiple things here. You cannot ever just divide an entire function out. So if we divided by sine of x on both sides, you'd get tangent x equals 1, and that'd be super easy. Unfortunately, you cannot do that because it's still there. So what you do if you've got multiple different functions is get everything on one side. That's what I would start with. So here, I'm going to subtract sine of x to both sides. Now, I can't actually subtract that because I can't subtract within, those aren't like terms, right? So what I have is sine x times tangent x minus sine x, and now this would equal 0. Do you agree with that? Do you have something in common in both of those terms? Yeah, what's in both of those terms? So would it be fair to factor out a sine x? And what would I be left with? Tangent x minus 1, yes? So now I have 2 factors there, don't I? I can set both of those factors equal to 0. This one's already solved, yes? So when we think about sine, where would sine equal 0? Well, it's got to be on the quadrant, on the axes, yes? It's got to be a quadrantal angle. Sine is which coordinate? Your y coordinate. So when we think of this, we'd go right 1 up 0, over 0 up 1, left 1 up 0, over 0, down 1. Where is the y coordinate 0? Between 0 inclusive and 360 degrees.
0 and 180.
0 degrees and 180 degrees. I agree. So for this one, x equals 0 degrees and 180 degrees. Now here, I would have to add 1, wouldn't I? And I would get tangent of x equals 1. Now, where tangent x equals 1 is 45 degrees. Do you agree with that? So when we think of this, where is tangent positive? All students take calculus. So it's going to be in quadrants 1 and 3, right? So when you draw your triangle in here, we're talking about opposite and adjacent. Yes? 1, 1 square root of 2, we know that is a 45-degree angle here. Everybody agree with that? So for quadrant 1, we know that's 45 degrees. For quadrant 3, we know this reference angle is 45 degrees, but how would I find the entire angle? 180 plus 45. So for this one, x would equal 45 degrees and 225 degrees. So my solution set would be x equals, start with the smallest one, 0. The next one would be 45 degrees. The next largest would be 180 degrees. And finally, 225 degrees, right? We want them listed smallest to greatest. Now, let's check that. Let's see if that is true. So first of all, I do need to be in degree mode. Here I have sine of 0 times tangent of 0. I want to know, does that equal sine of 0? Yep. What about 45 degrees? Sine of 45 degrees times tangent of 45 degrees. Does that equal sine of 45 degrees? Yep. 180. Sine of 180 times tangent of 180. Does that equal sine of 180? Yep. 225. Sine of 225 times tangent of 225. Does that equal sine of 225? Uh-oh. I did, oh, yep. How about sine of 225? Yeah, those two are equal. Yes? Questions? All right. Now let's look at example 3. What do you notice in example 3 that's different?
Tangent squared.
Okay, we do have a quadratic, right? Or something that resembles a quadratic, yes? And we also have radians. Okay? So let's think about this. If we had x squared minus 2x minus 3 equals 0, how do you solve for x? Or factoring? Yeah? So you guys do the AC method to factor, right? 1 times negative 3 is negative 3. We have 1 and 3. To get negative 2, what are we going to use? All right. You can factor by grouping at that point. Factor out an x and we'd get x plus 1. Factor out a negative 3 and we'd get x plus 1. So our factors would be x plus 1 times x minus 3. Yes? And you'd set each of those equal to 0. Do we agree? Now, you could also jump straight to where you know that this has to be x and x, and my factors of 3 have to be 1 and 3. This has to be negative, this has to be positive. Yes? So you don't have to necessarily do the AC method, but that is a tool to get to that. Yeah? We're going to look at this, and we're going to have to probably do something similar. And you don't have to think, you can think of tangent as u, you could think of tangent as whatever you need to do there. You could do a u substitution if that's what you need to do. But we're going to factor this like we factor a trinomial. Important to remember that we're talking about from 0 to 2 pi. Okay? And 0 is included, 2 pi is not. Yes? Everybody understand that? All right. So here, we essentially need to multiply 1 times negative 2. Do you agree with that? And we would get negative 2. So our factors have to be 1 and 2. And to get a positive, we're going to have a negative 1 and a positive 2. Yes? So when I do this, I'm going to substitute in a negative tangent x and a positive 2 tangent x. Yes? And now how many terms do I have? 4. And when I have 4 terms, I group. Here I could factor out a tangent x. And if you do that, you're left with tangent x minus 1. Here I could factor out a 2, and I'd be left with tangent x minus 1. Yes? So we have tangent x minus 1 times tangent x plus 2. Now, because this leading coefficient's 1, you could have jumped straight to this, right? Knowing that you have to have tangent and tangent, and you have to have 2 and 1, correct? So you could have skipped that step where you're doing both of these steps, actually. If you know how to go from here to here, that's fine. Most of you probably are going to need to do those steps. But if you don't, that's fine. All right, now we need to set each of those equal to 0. Tangent x minus 1 equals 0. And tangent x plus 2 equals 0. Here we add 1 and we would get tangent x equals 1, correct? And here we subtract 2, we'd get tangent x equals negative 2. Do we agree with that? All right. So for the 1, we know all students take calculus. We know it was in quadrant 1 and 3. We just did this one, didn't we? Here, we said this was 45 degrees, but in radians for quadrant 1, what would it be? Pi over 4, right? 45 degrees is pi over 4. And for quadrant 3, remember this was 45 degrees also, yes? This is pi, isn't it? So would it be fair to say this is pi plus pi over 4? Which is 5 pi over 4. If you need to do the 180 plus 45 and change it, that's fine. But I would strongly encourage you to start thinking in terms of radians because it's going to make your life easier. So we know those two are for this one. X would equal pi over 4 and 5 pi over 4. Now, when we talk about negative 2, tangent is negative in quadrants 2 and 4. So we know these have to be in 2 and 4. So if I'm thinking about this, tangent is opposite over adjacent. Do I have a special right triangle for that? I don't, right? So that means I'm going to have to use my calculator for that. So for quadrant 2, we have to consider our calculator is going to give us this reference angle. Do you agree? And I need it to be in radian mode. So I'm doing tangent of negative 2. So if I'm doing that, I'm looking for an angle. So how do I look for an angle?
Inverse tangent.
Inverse tangent. So inverse tangent of negative 2 gives me negative 1.07 whatever. Yes? What do you think I need to do with that? Because I'm looking for this angle. What did you do up here when you were in quadrant 2? 180 minus 30, right? This is my, yeah, so pi, and since it's already negative, right? Pi minus 1.107 whatever, yes? But since it's already negative, I'm actually going to add it, aren't I? So I would do in my calculator pi plus this negative thing right here, yes? And I would get 2.03444, and it just keeps going. Yeah? Now, we also have to look for quadrant 4, right? The calculator is giving me this reference angle. I need to find this entire angle here. So for quadrant 4, what would I do?
Add pi to what we just
Yeah, you could do that, right? Or 2 pi and then minus 1.07, whatever, yes? Is that fair? So 2 pi and then plus this negative angle here. And I would get approximately 5.17603, and it just keeps going, yes? So when I write my answers, I'm going to have x equals, quadrant 1 was pi over 4. Do you agree with that? Quadrant 2, we're going to say, we'll go to 3 significant digits. And here's the reason, because in calculus, that's what we do. For AP calculus, you have to go to at least 3 digits. So here we'll go to 3 digits, unless it tells you differently. 0, 3, 4 is what I'm going to call it. And then quadrant 3 was 5 pi over 4, correct? And quadrant 4 was, I'm going to call it 5.176. Now, if we check those, tangent squared. So I do what? Tangent of pi over 4 squared plus tangent of pi over 4 and then minus 2. And that equals 0. So that one checks, right? For this one, I would do tangent of, and I'd go up here and highlight this angle, squared, plus tangent of this angle, and minus 2. Now, it's going to give me something really close to that, right? Because my calculator rounded in there somewhere. Yes? But still, that negative 3 e to the negative 9 would be 0.000000 whatever, right? So that checks. Yes? And so you can see how you would check all of those. Does that make sense to you? Questions? Now, there can be extraneous solutions eventually, so keep that in mind that you do need to check your answers. Okay? This is more in the 6-3 that there's going to be more extraneous solutions. All right, let's look at example 4. Here it says to find all solutions. So before it gave us intervals from 0 to 360 or 0 to 2 pi, right? So first of all, this is going to be talking in radians unless it asks for something different. And when it's talking about all of them, we have to think about adding rotations, right? Because 45 degrees is an angle, but if I wanted all of the possible solutions, I could add 360 degrees to that and get the next angle, right? Because those are all going to be accurate, yes? So you have to think about adding rotations. What is a rotation in radians?
2 pi.
Okay. So, looking at this, it's really tempting to say, oh, well, I can set cotangent x equal to 1 and cotangent x plus 3 equal to 1. But can you do that? No. You have to have it set equal to 0, right? So first thing I'm going to do is I'm going to distribute this, and I would get cotangent squared x plus 3 cotangent x. And I'm going to go ahead and move my 1 over, and I'd get minus 1 equals 0. And so that should look eerily like a quadratic, right? Agreed? So if we do 1 times 1, can I get 3 out of that? So what's the other way that we can solve quadratics? Quadratic formula. So remember, your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So A would be 1. Do you agree with that? B would be 3. C would be -1. So cotangent x, not x equals, but cotangent x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get -3 plus or minus the square root of 9 plus 4 over 2. Everybody agree? So it would equal what? -3 plus or minus the square root of 13 over 2. So you have two possible answers here. You have cotangent x equals -3 minus the square root of 13 over 2, and cotangent x equals -3 plus the square root of 13 over 2. Do you agree? Now, I'm fairly certain that's going to be a negative answer. Do you agree with that? So this is going to be a negative, and this one, if you do -3, I mean, I can see right away, but if you do -3 plus the square root of 13, you're going to get a positive answer over there. Do you agree with that? So when we think about, we need that because we're going to be talking about what quadrants it could be in, yes? So is it fair to say that if this is cotangent, then tangent of x would equal 2 over -3 minus the square root of 13? The reason I say that is because I'm going to have to plug it in my calculator, yes? Those are definitely not going to be special right triangles. Everybody agree with that? Okay. And then the other one, this would be for the negative answer, and for the positive answer, tangent x would equal 2 over -3 plus the square root of 13. So let's figure out where those would be. So thinking of your quadrants there, tangent would be positive in quadrant 1 and quadrant 3. Yes? So for quadrant 1, inverse tangent of, I'm going to put this in as a fraction, 2 over -3 minus the square root of 13. And I'm in radian mode, so I should be good. I get -0.29400, and it just keeps going. So what is that giving me? Yeah, that's the negative one, so it's not in quadrant 1. Sorry, I should have been, I thought I was doing the positive one. All right, so the negative one would have been in quadrant 2 and quadrant 4. Yes? So what it's doing is it's giving me this angle right here, isn't it? That negative reference angle. So here we want it positive. So it's giving me this. I need this angle. So for quadrant 4, I guess we could do quadrant 2 first even. Let's look at quadrant 2, I guess. Quadrant 2, so for this one, what would I do? So I would do pi minus 0.294 whatever. So pi, and I'm actually going to add it because it's already negative, yes? And I would get approximately 2.84759, and it just keeps going. Now, I want you to think about something. You said earlier you could just add pi to that to get the quadrant 4, right? Yes? So if I continue to add pi every time, is that going to give me a solution? So I would have this plus pi times any number. We're going to call it n, and then we'll define n as any number, any integer. Yes? Make sense? All right. So that's for quadrant 2 and or quadrant 4. Now let's look at the positive one. So positive would have been in quadrant 1 and quadrant 3, yes? So for quadrant 1, we would do 2 divided by negative 3 plus the square root of 13. Oops. And I get 1.276795, and it just keeps going, yes? Now, if I was to find this one, I would do what? Add pi to it, right? And then if I find this one, I could add pi, and I could keep doing that, couldn't I? So I would add pi times any number to that one also, yes? Is that fair? All right. So my solutions would be x equals, and I would say this is 2.848 plus pi times n. And here I would say this is 1.277 plus pi times n. Now, would it have been wrong if I had said negative 0.294 plus pi times n? Is that an equivalent angle? It is, right? Because I got that negative there, and when I added pi to it, that's how I got my positive angle, yes? So I prefer them not to be written as negatives, but that doesn't mean it's wrong, right? Does that make sense to you? It's a preference, unless it tells you where all angles are positive. Yes? All right, one more example. So solve tangent x plus square root of 3 equals, actually, I'm going to replace this one. I'm going to replace it with cosine squared theta minus sine squared theta equals 0. And we're going to go ahead and go in radians though, so there we go. Anybody have? Mm-hmm. You guys got to keep telling me that. Anybody?
2 cosine theta.
Okay. If you recognize that, you could totally use that. Absolutely. Anybody have another suggestion? If you didn't recognize it as 2 cosine theta? Actually, it'd be cosine 2 theta.
Oh, okay.
Right? And then that, which we're going to do in section 6.3, we're going to do some double angles, but it does change things just a little bit. So we're not going to use that one right now. But yeah, it would be a double angle identity, cosine 2 theta. What else? What else could you do? What's cosine squared? Could we change cosine squared in terms of sine? Yeah, because we know sine squared theta plus cosine squared theta equals 1. Do you agree with that? So if I wanted it in terms of sine, I could change this and I could say cosine squared theta is 1 minus sine squared theta. Is that fair? Yeah? So would it be fair to say this is 1 minus sine squared theta minus sine squared theta equals 0? Yeah? Which would be 1 minus 2 sine squared theta equals 0. So when you said this is cosine 2 theta, it is, right? This is also cosine 2 theta, isn't it? You know what I mean? All right, so here subtract 1. Then we have negative 2 sine squared theta equals negative 1. Do you agree? What would we do next? Divide by negative 2. We get sine squared theta equals 1/2. Here's where you can get some solutions that don't work, some extraneous solutions. When we take the square root of both sides, that can cause some extraneous solutions. So sine theta would equal the positive and the negative, right? 1 over, because square root of 1 is 1, over the square root of 2. Do we agree with that? So then when we think about sine, positive or negative, we're talking about all 4 quadrants, yes? So here in quadrant 1, if this is theta, the opposite over hypotenuse, what's that going to be? 1 and square root of 2, right? Is that a special right triangle? What angle measure is this? 45 degrees, pi over 4, right? So for quadrant 1, we're at pi over 4. For quadrant 2, how can I get that? This is pi, isn't it? And my reference angle is pi over 4, so what's the entire angle here? Pi minus pi over 4, which is 3 pi over 4. I agree. For quadrant 3, now we're talking about pi plus pi over 4. Do you agree with that? Yes? And pi would be 4 over 4 plus 1 over 4 is 5 pi over 4. And then quadrant 4, we would subtract it from 2 pi. So 2 pi minus pi over 4 would be 8 minus 1 is 7 pi over 4. So we have 4 possible answers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now let's check them. And so here I would have cosine of pi, oops. Would it be fair to check it in degree mode? Could you check it in degree mode? You could if you wanted to change them, I guess. But all right, cosine of pi over 4 squared, yes, minus sine of pi over 4 squared. 1e to the negative 13, is that 0? Is that equivalent? That'd be 0.0000000000013 zeros 1. Yes? Yeah, equivalent? All right. Then we'd do the same thing with 3 pi over 4. I probably ought to just do... Yeah? Equivalent? 1e to the negative 13. So what we're talking about here, when it says 1e to the negative 13, you're talking about 0.0000 5, 6, 7, 8, 9, 10, 11, 12, 1. Is that 0? Point. That many zeros is going to be 0, yes? Okay, so your calculator can't calculate it exact. It's rounding somewhere in there. Here, same thing, 5 pi over 4. You're looking at an approximation, but it's pretty close. Same thing, yes? Negative 1 point whatever, that's still going to be 0, yes? And 7 pi over 4... Same thing, 2.9e. And yours might look slightly different than mine, but it's still going to be that 0.00000 really close to 0. Yes? Questions. So all 4 of those would be solutions. Sometimes they will result in something that's like it equals 8 or 80 or something like that. And 80 is definitely not close to 0, right? So that's what we're looking for. All right, so solving trig equations. This is just some guidelines here. Decide whether it's linear or a quadratic form. So you can determine whether you're just going to solve for x or if you're going to have to factor or use a quadratic formula, whatever. If only one trig function is present, solve the equation for that function. If more than one trig function is present, rearrange the equation so that one side equals 0. Try to factor and set each factor equal to 0. If the equation is in quadratic form but not factorable, use the quadratic formula. Check that solutions are in the desired interval. Try using identities to change the form of the equation. It may be helpful to square both sides of an equation first. If this is done, check for extraneous solutions. So make sure that you pay attention to that. If you're squaring both sides, check for extraneous solutions. If you're taking the square root of both sides, check for extraneous solutions. So back here where I said negative 0.294 would be acceptable, it would have because it said to find all solutions. If it had said between 0 and 2 pi, would it have been acceptable? No. Does that make sense to you? So you got to make sure you pay attention to if it's in a specific interval, that it's in that interval. If it says all, you got to consider your rotations. Are we good? Questions? Okay.